Welcome to the tutorial video series for the Integrated Environmental Control Model, or IECM. These videos are designed to show you various aspects of the IECM to help you understand how it works and how you can use it in your modeling efforts. You can find more information, including additional videos and our user manual and detailed technical documentation, on our website at www.iecm-online.com. This video will give you an overview of the interface and show you some of the main components and features of the model. If you are new to the IECM, this is a good place to start. Let's get started. When you first start the model, a splash screen appears, followed by a small window with a couple of menus and 3 buttons: New Session, Open Session, and Exit. To create a new power plant model, you can either click New Session in the File menu, or just click the New Session button on the toolbar. A New Session box appears, prompting you to make a selection. In the New Session box, you first choose the power plant type that you would like to model. The first option is a pulverized coal-fired, or PC plant. The second option is a natural gas combined cycle, or NGCC plant. And the third is an integrated gasification combined cycle, or IGCC plant. There is also a box where you can name your plant. I'm going to select a pulverized coal-fired plant, name it PC, and click OK to create it. When I click OK, a new window comes up. This window is the starting point for modeling the power plant. Looking at the toolbar on the top, you will see buttons that give you shortcuts for some common operations, along with a summary of which screen you're currently looking at. If you hover over one of the buttons, a brief description of that button will pop up. Moving to the status bar on the bottom, you will see a reminder that you can right-click values for additional options. There is also a note summarizing some important financial information. And finally, looking at the navigation area on the left, you will see 4 sections: Configure Session, Set Parameters, Get Results, and Analysis Tools. Analysis Tools is beyond the scope of this video. We're going to look at the first 3 sections. Configure Session is where you configure the broad overall design of the power plant. This section contains the plant design screen, where you choose the equipment for the plant location screen, where you choose the region in which the plant is located, and the unit system screen, where you choose the overall unit system to be used in the IECM, as well as your preferred units for certain types of results. We're going to look at the plant design screen in more detail, but first, let's take a quick look at the other sections. Each section has a box next to it that you can click to show or hide its contents. You cannot collapse the section that you are currently in. Clicking on the section title will take you to the first screen in that section. Set Parameters is where you can specify the input parameter values for each of the power plant components. Under Set Parameters, there is a series of sections corresponding to various areas of the plant. Some of these sections correspond to a specific component. Others may contain multiple subsections depending on your configuration. For example, the NOx control section, which is not currently shown, may contain subsections for both pre- and post-combustion NOx control if you have chosen both options in your plant design. Each component has a series of screens containing all of the parameters for that component. There are a lot of parameters here, and we will return to these in more detail later. Get Results provides you with the model output, where you can look at the resulting mass balances, plant performance, and total costs of the overall power plant, or for individual pieces of equipment. For example, if you want to know about the efficiency and costs of the overall plant, You can find these results in the Overall Plant subsection of Get Results. On the Plant Performance screen, we see that this plant has a net efficiency of about 40% and a net heat rate of about 8,600 BTU per kilowatt hour, all based on the higher heating value of the fuel. On the Cost Summary screen, we see that this plant has a total capital requirement of about $899 million and a revenue requirement of about $45 per megawatt hour, expressed in constant 2017 US dollars. This is the cost of generating electricity from an environmentally uncontrolled power plant. As explained in the model documentation, this is also the default value used throughout the IECM to quantify the cost of electricity that is used by other plant components to control environmental emissions. Let's go back and configure a real plant. In the Configure Session section on the Plant Design screen, a simple schematic diagram of the power plant is shown. We start with the base power plant with no environmental control systems. Coal is fed into the boiler and burned to produce steam, which is used to generate electricity. Some of the ash in coal falls out of the bottom and is sent to disposal. The hot flue gases from combustion first pass through an air preheater to recover some of the heat, then flow through the stack out to the atmosphere. Real plants would be built to meet a certain level of environmental emissions constraints. The IECM has a number of technologies that can be added on to the base plant configuration to meet those constraints. For a pulverized coal power plant, you can add an electrostatic precipitator, or ESP, which then shows up in the plant schematic. Many older plants in the U.S. look like this, as do many coal-fired plants in other parts of the world. Any new plant built since 1977 must also have a flue gas desulfurization system. Here we have some options for sulfur removal, the most common being a wet lime FGD system. As well, new power plants today require a post-combustion NOx removal system, in addition to in-furnace NOx controls. A water cooling system other than a once-through system is also required to prevent thermal discharges. These plants would typically use a circulating water system that includes a wet cooling tower. In this menu, the IECM has several standard pre-configured plants to choose from, or you can configure your own specific design. Broadly, there are in-furnace combustion controls for controlling NOx, and there are also post-combustion controls for NOx, particulates, SO2, mercury, and CO2. There are also multiple options for plant cooling water, wastewater treatment, and disposal of fly ash and FGD wastes. When any of these options are selected, the plant configuration picture changes. You will also notice that some options in the pop-up menus are sometimes grayed out. This means that they are not compatible with the current configuration. For example, the amine CO2 capture system requires post-combustion NOx control and will be grayed out if you have not chosen that option. The details for specific technologies are outlined in other video presentations as well as in the user documentation. For this example, I'm going to choose a typical new plant. This configuration is designed to meet the New Source Performance Standards, or NSPS, which is a set of current federal regulations for environmental emissions. Once the configuration has been chosen, you next go to the Set Parameters section to set the size of the plant, set up a financing structure, and configure the main components. The first subsection gives you options for the overall plant, and all of the screens it contains are big picture items for the plant. When you click on Performance, A new screen appears that allows you to view and specify a number of variables that are related to the overall plant performance. Each variable is listed under Title, and the units are given. Every parameter has a default value that we've chosen to be representative if you don't have your own value to specify. There is also a minimum and maximum to help catch typos and prevent errors. The variables have deterministic values, but they can also be assigned probability distributions for looking at uncertainty. The buttons in the UNC column bring up the uncertainty editor, and a question mark on the button indicates that uncertainty has been assigned to the associated variable. Some variables depend on other parameters and may be automatically calculated. This is indicated by the presence of a checkbox in the Calc column. If this box is checked, the variable is currently being automatically calculated. In most cases, you can click the box to clear the checkmark and override the value. If a variable is highlighted in blue, it means that it usually varies from one plant to another and has a significant impact on performance or cost results. So in this case, you should think carefully about whether you want to accept or change the default capacity factor, since it is going to have a major impact on costs. To change the capacity factor to 80%, you simply edit the value like you would in a spreadsheet and hit Return when you're done. The screen is redrawn and all automatically calculated variables are updated. Notice that there are a few variables that are grayed out, meaning that they cannot be changed here. In some cases, such as ambient air humidity, the value is calculated from other values and displayed strictly for reference. In other cases, such as gross electrical output and plant location, the value is displayed for reference, but we prefer that you change it in its primary location to minimize the possibility of errors. In these cases, there is a note telling you where you can go to view and change the value in its proper context. Moving on to the Regulations and Taxes screen, you have options for setting the air pollutant emission limits for the plant. This, in turn, automatically configures some of the environmental control equipment which you previously selected on the plant design screen. Emission taxes are also specified on this screen. The Financing and Cost Year screen allows you to set up the overall financing structure of the power plant. This is an important screen, and there is a separate IECM video that walks you through it in more detail. Some key information from this screen is displayed at all times in the status bar. There are also important screens to specify the unit costs or price of all plant materials and labor. Regional factors that affect these costs can be adjusted on the region-specific cost factors screen. In the Fuel subsection, you can view and edit the properties of the fuel being used at the power plant. The IECM also has a fuel database, so you can select from a variety of commonly used fuels. Currently, an Appalachian medium sulfur coal is selected as the default, but you can change this to, say, an Illinois No. 6 coal by clicking the Click Here to Retrieve a Coal from the Database button at the top of the screen, then selecting Illinois No. 6 from the Coal Name menu in the window that pops up. You click OK to confirm the selection, and the IECM pops up a window telling you that the coal was imported successfully. This screen also includes a default cost for the fuel, which you can change if needed. There is a separate IECM video that takes you through the screen in more detail, including how to specify and save your own coal properties. Other screens in the Fuel subsection allow you to specify ash properties, auxiliary gas properties, and mercury in the coal and its speciation. You can also view a summary of the costs. The base plant subsection is where you can specify a number of critical plant parameters, including the gross power plant size, the steam cycle type, and other important parameters. For parameters where the calc box is checked, you have to first uncheck the box before you can change the value. So, to change the gross electrical output on the base plant performance screen to 500 megawatts, I first click the calc box, then enter the new value. The other subsections depend on the specific technologies that you have chosen on the plant design screen. The details for each of these technologies is provided in the IECM user documentation, and there are a number of videos that deal with options for CO2 capture and storage as well. As mentioned earlier, results from the overall power plant and individual pieces of equipment can be found in the Get Results section. For example, looking at the overall plant performance, we see that, with the environmental controls, the net plant efficiency is now about 38%. The costs of the overall plant are around $980 million, with a revenue requirement of about $62 per megawatt hour. You can also look at the flow rates of solids and gases for the overall power plant or for individual pieces of equipment at various points. Let's look briefly at some of the other model options. You can easily open up multiple sessions in the IECM by selecting New Session from the File menu, or by clicking the New Session button on the toolbar. A new session screen comes up as before. For this new plant, I'll choose the Natural Gas Combined Cycle option, call it NGCC, and click OK to create the session. Now we have two power plants open in the IECM. The overall structure of the plant design screen is the same, but in this case the schematic for the natural gas combined cycle plant is simpler than the coal plant. Gas is piped directly into the facility and burned using compressed air. A gas turbine is used to generate electricity, and the heat from the gas is recovered in a heat recovery steam generator, which is used in a steam cycle to generate additional electricity. The flue gas is vented out of the stack, and there are fewer environmental control options because the flue gas is already clean. I'm going to open one more new plant. This time it will be an integrated gasification combined cycle plant, and I'll name it IGCC. In the base case design, coal, water, and oxygen from the air separation unit all enter the gasifier. They react at high temperature and pressure to produce a synthesis gas, or syngas, which is treated to remove particulate matter and sulfur. The clean syngas then goes to a power island, where a combustion turbine and a steam turbine are used to generate electricity in a combined cycle, just as with the NGCC plant. The flue gases are then sent to a stack and vented to the atmosphere. You can save sessions in the IECM just as you would save files in a word processing program. To save a session, click Save As in the File menu, or click the Save As button on the toolbar. This brings up a window which allows you to choose a database and edit the session name. In some installations, a database called SesDB is created in the folder where the IECM was installed. You can use that database if it exists, or create or open a different database. SesDB does not exist in my installation, so I'm going to create a new database. And save my session there. Now that the session has been saved, I can save further changes by clicking Save in the File menu, or by clicking the Save button on the toolbar. To open a saved session, click Open Session in the File menu, or click the Open Session button on the toolbar. Then choose the appropriate database, opening it if necessary, and the session you want to open. In this case, a star on the left indicates that this session is locked because I already have it open. The case studies included with the IECM are similarly locked to prevent changes. If I open a locked session, a copy of that session will be created, and the original will not be disturbed. We hope that this video has been helpful. To learn more, we invite you to check out the other video tutorials and documentation on our website at www.iecm-online.com.